Let's hope this works well. So here's our example. We're given one line. Let's call it L. And the points in that line are defined as -5, 3, and 4, -6. We are told to find the distance between this line and point P called 2, 4. Let's imagine what they're asking us to do. They're saying that, quick sketch to aid us in our visualization, they're saying that -5, 3, +4, -6, that line, they want to find the point 2, 4. Let's say we go over 2, up 4, the distance between this point and that line. Now, the construction has given us some help. What's the shortest distance between a point and a line? You think I should go from here to there? No, I'm going to take a perpendicular. Okay? I'm going to take a perpendicular approach. So here's the approach. Why don't I do this? Why don't I find the slope of that line? Okay? Why don't I find the equation of that line where it intersects, the y equals mx plus b of that line? Because the b is going to be where x is equal to 0, right? That's where it's going to intersect. That makes sense. Why don't I find out, by finding the slope of this, I will know the slope of this line, won't I? Because the slope of this line has to be the negative reciprocal of this slope. That's a relationship of perpendicular lines. Once I have the slope of this line and I know one point, I can find the y equals mx plus b of this line. It's a lot of work. There are many steps, but I'm just talking about things that we know we can do. Once I have the y equals mx plus b of this line, I can solve simultaneous linear equations and find out the point of intersection. Once I have the point of intersection, I have 2 points and I can find the distance. Let's proceed. First step, slope. M equals y2 minus 6 minus y1, 3, divided by x2, 4, minus 5, which is plus 5. So we have -9 over +9. -9 over +9, that's a slope of -1. And that looks appropriate. That's a negative slope. I know that the slope of this already has to be what? The negative reciprocal of -1 is +1. So this slope is +1. You just write 1. Nobody writes +1, right? Let's continue with this. We have the slope of this. Let us now find the y-intercept. How do I find the y-intercept? Here's what I know. The equation for this first given line L has to be y equals mx plus b. I've just solved for m. It's -1. So y has to be equal to -1 times x. -1 times something is just the negative of the number, so it's -x plus b. We know the points. We know 2 points on that line. So if I were to insert this as x and this as y, that solves for b. So I replace x with -5. A negative of a negative becomes +5 plus b is equal to, what was that? That was 3. So subtract 5 from both sides. B is -2. We now have the equation, the complete equation for this line, which we needed. It is y is equal to -x minus 2. That's the equation for the first line. Let's get the equation for the second line. What do we already know about the second line? We know the slope of the second line, and we know a point. All we need is a slope and 1 point to find b. Let's do that. Y is equal to 1x, so we just say x plus b. 1 point on that line, the only point we know is 2, 4. X is 2, y is 4. So when y is 4, x is 2. Subtract 2, subtract 2. We have a b equal to 2. We now know the equation for this line completely. The equation for this line is y is equal to x plus 2. We now have to find where these two lines intersect. This is a relatively simple equation, okay? What we can do with this is we can just say, since y is equal to this and y is equal to this, well then where they are both equal to each other, at this y, the x values have to be the same. So we say, since y is equal to this and y is equal to this, by substitution, x plus 2 has to be equal to minus x minus 2. So, that's where x is equal to 0. So, resume, moving too quickly. Add x to eliminate that. 2x plus 2 is equal to negative 2. Minus 2 minus 2, 2x is equal to minus 4. Divide by 2, divide by 2, x is equal to negative 2. That's the solution for where the x value, where these two lines intersect. These two lines intersect where x is equal to negative 2. The next step is to solve for the y value, plugging this x in any equation. So let's use this equation, the second line. Y is equal to, x is replaced by negative 2 to find out what the y value is. Negative 2 plus 2. So the y value is equal to 0. Here's what we've just found. We've found the coordinates of the point of intersection. The coordinates of the point of intersection are x negative 2, 0. So the problem now becomes the distance between negative 2, 0 and point 2, 4. That was the given point. We use the distance formula. Distance is equal to the square root x2 minus x1 squared plus y2 minus y1 squared. x2, x1, 2 minus minus 2 is 2 plus 2 squared. 4 minus 0 squared. Of course, everything under the square root. So that's 4 squared plus 4 squared. That's 16 plus 16 squared. It's the square root of 32. That is our distance. Quick review. Use the points to find the slope. Use the slope and 1 point from the first line to get the equation of the line. So you have the equation of the line for the given line. Use the slope, inverted and reciprocal, negative reciprocal for perpendicular lines. Use that slope and the one given point on the new line to find the equation of that line. Solve a system of linear equations. You can use elimination or substitution. This was a substitution method that I paused at because it didn't look right at first. It's been a while. So use substitution to find x. Use that value in either of the two equations that you created, either the equation for the first line or the second line. Use those to generate y. Now you have an x and a y. That x and a y are of the point of intersection. Now you can find the distance between the 2 points using the distance formula. All right, that was a tough one, guys.